All right, let's talk Wi-Fi. You've got two completely different worlds. In one corner, you have that simple little box that runs your entire home network. And in the other, you have this massive, complex system that keeps a whole company online. They both give you Wi-Fi, sure, but how they do it? Well, they're not even in the same league.
And you can see the difference right away, can't you? On the left, that's the familiar SOHO router, small office/home office. It's the all-in-one gadget we all have. But on the right, that's a piece of enterprise kit. It's a wireless LAN controller, or WLC. It just looks more serious because its job is way, way bigger.
So that really gets to the heart of it. What is the real difference here? I mean, besides one being bigger than the other. I'll tell you right now, it's so much more than just a stronger signal. We're talking about a fundamental split in how they're designed, how they're secured, and how they're managed.
Okay, let's kick things off on familiar turf. Let's talk about the device most of us have sitting in a corner somewhere, blinking away, the SOHO router. This little box is the command center for our home internet.
Now, here's the thing. We call it a router, but that's not the whole story. It's really more like a networking Swiss Army knife. It's actually 3 different devices all packed into one plastic shell. The router part is what gets you out to the internet. The switch is what gives you those physical ports you plug your computer or your PlayStation into. And the access point, that's the part that beams out the Wi-Fi signal.
So, you take one of these out of the box. What's the very first thing you should do? Security. Seriously, you log into it, usually with a super common password like admin or password, and your absolute #1 priority is to change that immediately. If you want to go a step further, you can change the default network numbers just to make it a little less obvious for anyone trying to snoop around.
Okay, once it's locked down, it's time to actually get the signal going. First, you give your network a name. That's the SSID you see on your phone. Then you pick a channel. Quick pro tip, use channels 1, 6, or 11. They don't overlap, which means less interference from your neighbor's network. And finally, you set up WPA2 Personal Security. That's just the official name for the good old what's the Wi-Fi password system we all know.
But look, all this simplicity is great for a house. What happens when you try to cover an entire office building? This is where that simple all-in-one model doesn't just bend. It breaks, and it breaks fast.
And here's why it's such a disaster. Imagine you just scatter a bunch of home routers around an office. You've got 0 central management. Each one is its own little island. Roaming is a nightmare. Your laptop will cling for dear life to a weak signal from 3 rooms away instead of smartly switching to the router right over your head. Security? 1 password for the entire company. That's a huge risk. And when something goes wrong, good luck trying to figure out which one of the 20 identical boxes is the problem.
So this problem of scale required a totally different way of thinking. And the enterprise world came up with a brilliant solution. They split the network's intelligence from the hardware that actually pushes the signal. It's a move to a brains and bronze architecture.
And this diagram just lays it out perfectly. The wireless LAN controller, or WLC, that's the centralized brain. It makes all the decisions, handles all the security, all the configuration. Then you have the access points on the ceiling. They're now lightweight APs. They're the brawn, the muscle. Their only job is to be an antenna, to grab wireless traffic and tunnel it back to the WLC. They don't think for themselves at all.
And the payoff for doing this is incredible. You get one single dashboard to rule them all. An IT admin can see in one place the health of every single access point, how many people are connected, and, this is critical, if there are any unauthorized rogue devices trying to get onto the network. This is what true command and control looks like.
Okay, so this all sounds great, but how do you actually build one of these things? Well, you have to shift your thinking away from configuring one box. It's more like you're building a logical pipeline for your data to flow through.
And this shows you the anatomy of that pipeline. It's all done in layers. A user connects to the Wi-Fi name, the SSID. That's mapped to a virtual interface inside the controller. That interface then gets tagged with a specific VLAN, a virtual LAN. And VLANs are the secret sauce. They let you digitally slice up your network so that the guest traffic can be completely walled off from the sales department traffic, even though it's all running on the same physical hardware. It's incredibly powerful.
Now, to get there, you've got to build the foundation first, the plumbing. On the left, you create the VLAN interface, which is like the gateway for every device in that virtual network. Then, on the right, you have to create a matching DHCP scope. That's just the pool of IP addresses you're going to hand out. And here is the golden rule you cannot break. The network numbers for both of these must match. If they don't, it's game over. Nothing works. But once you've built that back-end plumbing, creating the actual Wi-Fi network that people see is pretty straightforward. You give it a name, you enable it, and then, this is the magic moment, you map it to the VLAN interface you just created. And just like that, you've connected the wireless signal to the right pipe in your network.
Now let's talk about maybe the single biggest differentiator of them all, security. Enterprise networks go so far beyond a simple password. They use this really robust system we can call the trust triad.
This triad has three core players all working together. You have the WLC, which is enforcing all the access rules. You have a radius server, which acts as the gatekeeper, checking everyone's ID. And you have an SNMP server, which is the watchdog, constantly monitoring everything and logging what happens. They're all in constant communication to keep the network secure and manageable.
So what exactly is this radius server? Think of it as the ultimate bouncer for your network. It handles what we call the 3 A's. First, authentication. Who are you? It checks your username and password. Then authorization. Okay, you're in, but what are you allowed to do? It decides what parts of the network you can get to. And finally, accounting. What did you do while you were here? It keeps a detailed log. This gives you individual accountability, which is a massive leap forward from a shared password.
Now, for this whole system to be secure, all the parts need to trust each other. So here, you're seeing the WLC being told to trust the Radius and SNMP servers at their specific IP addresses. And they prove their identities to each other using a shared secret. This is basically a very strong password that only the network devices themselves know, making sure the WLC is talking to the real gatekeeper and not some imposter.
And here's the final piece of the puzzle. You go into the Wi-Fi network settings and you switch the security to WPA2.enterprise. That one change tells the WLC, stop using a shared password. From now on, send every single connection attempt to the Radius server to be verified. As you can see in the flow here, a user connects, the WLC challenges them, their info gets checked by Radius, and only after Radius gives the thumbs up do they get on the network.
Of course, just building the network is only half the job. A true enterprise system isn't something you set and forget. It needs professional-level maintenance and constant optimization. When something goes wrong, you don't just start randomly rebooting things. You use a system, like this troubleshooting funnel. You start at the top, with the easiest thing to check, the client's device. Is their Wi-Fi even on? Do they get an IP address? If that's all good, you move down to the environment. Is there some kind of physical interference? Only after you've ruled all that out do you start digging into the core infrastructure, like the controller and the switches.
And it's not just about fixing what's broken, it's about being proactive. Active management is absolutely key. This means keeping firmware updated on everything to patch security holes. It also means fine-tuning performance, using clever features like band steering to gently push newer devices onto the faster, less crowded 5 GHz frequency, leaving the older 2.4 GHz band free for the devices that need it.
So, we've gone from a simple all-in-one box to a complex, centrally managed system. The big theme in that evolution was moving the intelligence to a central brain for more control and better security. So this leaves us with one last question to chew on. What's the next big leap? Are we moving beyond just centralized control into a world of fully autonomous, AI-driven wireless systems that can manage, optimize, and even heal themselves? Now that's an interesting thought.